Hello everyone, my name is Ryan, coming to you from the DL Academy, and this is the continuation of our Sudoku solver um, algorithm using Python. So if you don't know Python, make sure you go check it out at our website, thedlacademy.com, and use this link for 50% off. Now let's get started. So this is where we left off at the previous video. We were basically dealing with whenever we fill up an entire row or column and then we block at a certain point and we have to move back, so this takes care of the moving back. Now else, this means if we find an array, so the array was already created, but we still have new possibilities. So we still have, for example, we still have a 5, an 8, and a 9. So we still have possible numbers that we can put in the position. So in this case, we're going to be set the position to the new value. So we're changing the value at a certain position. So this is where we're going to be doing. We're going to be first saying try and catch statement, because try and accept, because I noticed that this part caused some issues without the try and accept statement, so I added it and it worked. So we're going to be saying Sudoku I comma j, which is the Sudoku at our current position, is going to be equal to mega array. And then here we're going to be taking the b, which we were looping through, 0, which is all our possible solutions. And then here, this is our new index variable that we created. All right. And then I noticed that if this doesn't work, then we have to say new index -1. And this fixes the issue. And then we're going to be saying if j is less than 9, then we want to, so this took care of increasing the index. Now we want to move forward. So if j is less than 9, we want to run the recursion. So solve Sudoku, we pass in the Sudoku, and then here we're going to type in I, and then j plus 1. All right. Here we have an else, meaning j is equal to 9 or above. We're going to be saying solve Sudoku, so we're running the recursion with I plus 1, and then here is 0. So we're setting back to 0, so it's going to restart from the first column, but it's going to increase the rows. So that takes care of the else statement. Now let's exit the for loop, all right? And this is very important. We have to exit the for loop. So this is outside the for loop. The for loop only runs if we have elements inside our big array. All right. So this means that whenever we come back, where was it? So we were looping through the mega array. So that way, whenever we're at a case here, whenever we're at the position that we already went through, we can deal with it because we already have the array, all the possibilities and all the indexes and everything. We already have them stored inside the mega array. Well, let's say this is the first time, so let's say we were moving in a linear fashion and we reach this case, this position right here, but we've never been here before. So this has to happen outside the for loop, because if the mega array is empty, then this recursion will never happen, meaning that we can reach this point. But if this recursion happens, then we'll never reach this point, which is exactly what we want. So outside the for loop, we're going to be saying if Sudoku I and j is equal to 0, because if there's a number, of course, we want to skip it. But if it's equal to 0, then we have to add elements to this mega array. So let's create a variable, call it array, or ARR, equals get all possible answers, pass in the Sudoku, and then of course I comma j. So this gets all the possible answers, and then we're going to be saying if length of this array 0 is equal to 0, meaning there's no possible solution, then we want to move back. All right, so we gotta move back. This is the same thing that we did before. We just have to do it again. So we're gonna be saying, of course, we gotta get the coordinates equals mega array. So here we're gonna be saying coordinates equals mega array b and then 2. So here it's going to be equal to mega array b2, which is this b right here. So after going, so basically it's going to be equal to the length of the mega array. So b2, and then we're going to be creating an x and y variable. We're going to be saying equal to coordinate. So basically equal to coordinate. So x is going to be equal to coordinate 0 and y is going to be equal to coordinate 1. And then we're going to be saying Sudoku x and y equal to 0, same thing as we did before. Let's also get the index. So index equals mega array b1, and then we're going to say if index is less than the length of mega array b0, which is our possibilities, then we want to simply increase the index. So mega array b1 equals the index plus 1. So we increase the index, and else all we have to do is say mega array b1 equals 0. So we're resetting the index back to 0 if the index is out of range, or if the index increased beyond the length of our possibilities array. And then all here we have to do is say run the recursion, so solve Sudoku with Sudoku, and then coordinates 0 and coordinates 1. Alright, so let's also add a quick else statement. So here we're saying if the length of our array equals to 0 and we're outside of the loop, meaning it's the first time at the 0 position. So if it's our first time at the 0 position and we have possible answers, so else, this means we have possible numbers that would fit the Sudoku at that particular position, we can say mega array dot append. So we're going to be adding the array to the mega array, and then we're going to be saying Sudoku I and j is going to be equals to this array that we just added, but we have to take the first so the 0th index to the first element, and then this gives us all the possibilities. Take the first possibility of all these possibilities and assign it to that particular position inside the Sudoku. Now we're going to be saying if j is less than 8, we have to move forward. So solve Sudoku with the Sudoku, and then here I and then j plus 1. And otherwise, we have to go down a row. So solve Sudoku with the Sudoku I plus 1 comma j. Alright, so all we do here is we're assigning a so this is when we're going in a linear fashion. This is the first time we encounter a position, so a case right here. So it's the first time we encounter a box with a 0 in it, and we have a possibility. So because if we don't have a possibility, then we run this code, we're simply going to move back. But if there is possible numbers that we can put inside the array, we're simply going to add these possible numbers to our mega array, but we're also going to be setting the current position of a Sudoku to the first possible answers of all the possible answers. Hope that makes sense. So that's it for today's video.